Thank you all for allowing me to speak here with you today. Every tech revolution creates massive infrastructure opportunities. Mobile has created the need for cell tower infrastructure. The internet has created the need for data center infrastructure. Quantum computing is creating the need for specialized cooling infrastructure. I'm Christopher Cassin from 0 Point Cryogenics, and we are solving the infrastructure bottlenecks that are limiting quantum deployment. This is the Boomerang Nebula. It is the coldest place in our universe at minus 272 degrees Celsius. This is approximately the same temperature as our warmest product offering. Our systems get logarithmically colder from there. 0 point energy is the least amount of energy a single particle of matter can have. We are named after this fundamental phenomena. Quantum bits or qubits are delicate. The smallest amount of heat, often referred to as thermal noise, can remove them from their quantum state. This is called decoherence. Cold is quiet. Our job as a cryogenics company is to remove thermal noise. This is a dilution fridge. Our technology is so ubiquitous with quantum computing that if you Google quantum computer, it actually returns image results of dilution fridges, like these pictures here. There are 6 companies in the world that manufacture dilution fridges, 3 in North America and 3 in Europe, with the market leader being in Finland. This is a dual-use technology. It is critical to our national sovereignty as a country to produce these cryostats in Canada. We get requests from around the world, from Japan, from South Korea. We get requests from Austria, Australia, India, and the United States to build these cryostats. And this is something we're building right here in Canada. Let's talk about the fun parts. The best way to think of a dilution fridge is very similar to the air conditioning unit in your house or in your vehicle. The only difference is it uses liquid helium as a circulating fluid because everything else is a solid at these temperatures. These systems cool down in 24 hours or more, and they get to a base temperature of minus 273.14 degrees Celsius. The current state. Qubits are becoming more stable. Error correction is improving. In the near future, we're going to see at-scale facilities like what ICI Quantum is building at IQMP in Chicago. AI has accelerated our thirst for data. This is not going to stop. We are going to continue to have more and more thirst for data. Cryogenic solutions and wiring are really limiting quantum deployment, and we as a company are very well positioned to help solve that problem. Our quantum future. Civilization has difficult problems. How do we encrypt and transport data so that it does not fall into the wrong hands? How do we feed 10 billion people? How do we optimize transportation to lower our carbon footprint? Quantum holds the promise to help solve these problems, and it requires cryogenics in order to do so. We don't just hire PhDs. We are creating jobs for technical school graduates and providing them with alternative opportunities in Alberta to oil and gas. We are currently hiring a person a week and employ over 30 people. Today, tens of thousands of GPUs and CPUs work in concert to solve very difficult problems. Tomorrow, tens of thousands of quantum processors will need to be cooled by cryogenic infrastructure, and we are uniquely positioned to solve these problems. I'd like to now talk about our phase separation refrigerator. It's a great example of how innovative we are. This is the first time in 60 years a new form of cooling has been created below 1 Kelvin. This is a technology that is invented here in Canada and already starting to be adopted globally. It has a base temperature of 500 millikelvin. It cools down in less than 12 hours, and our scientists believe that they can get it to 8. This is already half the time it takes for a dilution fridge to cool down. It uses 85% less helium-3 than a dilution fridge, and if all of you aren't aware, in Canadian dollars, a single breath, that's $5,000 worth of helium-3. An average dilution fridge is using $100,000 Canadian worth of this precious gas. It has a 20% lower cost of ownership and uses 33% less wiring for the customer than a dilution fridge does. We've already received a patent in the United States, and we're going to be patenting this internationally. Case study. We have a wonderful opportunity to be providing cryogenic solutions for Cubic. We're very grateful for that opportunity. Jerome from Cubic is speaking later today. We were able to research and design solutions that specifically suited Cubic's needs and deliver those systems in a timely fashion to them. Building cryostats is hard. Operating them does not have to be. We make hard things easy so that our customers can focus on what touches, moves, and inspires them. We have created a vertically integrated company where we can control the quality of every step of the manufacturing process: design and drafting, machining, welding, polishing and gold plating, and assembly. I'm not aware of a cryogenic company that takes care of every step of the manufacturing process so we can control quality and delivery times. Our doors are open. Please reach out. We would love to connect and show you what we are building. Thank you.